Okay, so I've had a request to do chapter 7. There's 6 or 7 sections. I doubt I'll be able to do it within a week, but you do have to be able to solve for x on one side. You do have to be able to measure a distance between two dots on a Cartesian line. You do have to understand angles based on triangle, right angle triangle, and being able to figure out based on SOHCAHTOA. You do have to understand the distance between the principal angle and the acute angle. And you do have to understand the exact values chart. You do have to understand how to find other trigonomic ratios from this information. And let's look at number 7, because that's stronger. 6 and 7 are stronger into the this chapter than others are. The others are pretty much stuff we've done, right? So let's look at 6 and 7. What does, and I'm not going to have time, if this is your case that you want me to go through all of chapter 7, to go into huge solves. So given that this is tan, notice it's negative. Figure out which, and notice we're talking about one cycle, 0 to 2 pi. Where is tan negative? Where is tan negative? Tan is negative here. And so it goes C, A, S, T. So tan's negative there, and tan's negative there. Which means this can exist in either this quadrant or this quadrant. But let's look at, we'll say it's in this one. If we're talking about a right angle triangle that goes to here, and tan in SOHCAHTOA terms is opposite over adjacent, that means the 3 here is the opposite, and the -4 here is the adjacent. Which means we can figure out the hypotenuse here. The hypotenuse is this squared plus this squared, the square root of those, 5. Which means I can figure out all the other values for this. Sine is 3 over 5. Cos is -4 over 5. Tan we've already been given, but cotan is just going to be the flip. Secant is going to be the opposite of cosecant, or cosine, and secant, or cosecant, is going to be the flip of sine. And there you go. That's for all 3. Now, if it's in the other section, you're going to get the similar thing, except that cosine is going to be positive. Let's see. Where else is... Oh, yeah. Where else is it negative? That quadrant and down below. Yeah, you're going to get cosine is positive and sine is negative. And pretty much everything else is going to be the same, except secant, that's going to be positive and that's going to be negative. So that's the other quadrant in quadrant 4. Now, let's see if these are true or not. Well, we already... Oh, why did it do that? Jesus. Now, let's see if these are true. Now, some of them are self-evident, but let's see if we can just prove this without just knowing that it's already true. This is true for sure. It's a commonality. But let's look at what we've been examining, which is right angle triangles in terms of SOHCAHTOA, right? In a right angle triangle of the unit circle, if the hypotenuse is 1, and let's just, we can name anything here. It's going to be, doesn't matter. But if the hypotenuse is 1, these will have to be less than 1. Okay, so let's say that this is 0.70. I'm trying to find legitimate ones. 30 degrees I should use. That's okay. Yeah, okay, let's just take 30 degrees cosine. So that's 0.866. Over here. And the other one will therefore be that squared -1 square root. The other one will therefore be .5. So this one over here will be 0.5. So in this case, if I was going to do SOHCAHTOA, it would be the cosine of this angle here is the adjacent over the hypotenuse. But hypotenuse is 1. So we can see that it's just the adjacent. If I was going to do sine, it would be the opposite over 1. But this is just hypotenuse, which is just 1. So it's just the opposite. Which also turns out that the x and y values where this line reaches are the same numbers, 0.866, 0.5. Which means that since sine is this, or sorry, cosine is this, the adjacent, cosine is the adjacent over hypotenuse, which is 1, cosine is equal to that. And sine is equal to the opposite, 0.5 over 1, or just the opposite. So it's equal to the opposite. This is just simply equal to the adjacent. We've already gone over that. But in tan and SOHCAHTOA, it's the opposite over the adjacent. But we've already discovered that sine is equal to the opposite. So we can replace the word sine with that. Anytime you have something that equals, you can replace it. And we've also discovered adjacent is cosine. We've therefore proven it knowing that SOHCAHTOA is true, that the opposite over the adjacent is true. And then in this case, the adjacent is equivalent to sine and the opposite is equivalent to cosine. Therefore, tan is indeed sine over cosine. What about this one? This one's a very basic one as well. And since we've already established that this over here is the same as cosine, and this over here is the same as sine, we also know from SOHCAHTOA that this is also known as A, and this is known as B over here, and this is known as C or H over here, C or H. And we know from Pythagoras' theorem that A squared plus B squared is equal to C squared. But remember, we're talking about the unit circle, which has 1 squared, which is 1. But we've also determined that side A is the same as cos, and side B is the same as sine. Therefore, cos squared plus sine squared is equal to 1. It's also a reason why cos and sine will always be related in terms of the 90 degrees. Because if in this triangle, for instance, if I'm talking about the cos 30, then we're talking about the sine 30. It's equal to that. But we can also do this, cos 60. Both of these squared would be equal to 1. And if you're in doubt, you can always put it in a calculator. So we're going to do sine 30 first, but we're going to show that cos 60 works too. So sine 30 squared. So grab your calculator, and we'll just keep it in degrees for now. And cos 30 squared, so times itself, plus, open brackets, sine 30 squared, close brackets, should equal 1. And it does. But what about, as I said, what will cos 30 squared plus cos 60 work? Open brackets. Yes, it does. So we discovered an interesting little thing, that this is also true. And you'll discover why in a little in time. So what about this one? How do we prove this one is true? Well, let's first start by multiplying both sides by sine pi. So I'm going to multiply both sides by sine pi, like that, sine theta. It'll disappear on the left. Suddenly we get this. It's equal to 1. But then we have to remember what secant is equal to. Secant is the same as 1 over sine. If I take sine and multiply by 1 over sine, I get sine divided by sine of the same angle, theta. Sine theta divided by sine theta is 1. So that is also true. What about this one? Is this one true? Well, we've got to go back to variations of this one and just isolate cos squared here. We know this is true. We've proven it. So let's get cos squared. See how the cos squared's all on its own here? Let's go cos squared all on its own here by subtracting sine squared from both sides. So I'm going to subtract sine squared from this side. There it is, subtracted. and from the other side, because we know this one that I'm working on here is true. Well, sine squared minus sine squared here is that. So we actually get that cos squared is equal to 1 minus sine squared. But this said cos squared is equal to sine squared minus 1, which is not true. What about this one? Okay. Well, let's try to remember what tan squared is actually. Tan, as we've discovered, is the same as sine over cos, both squared, right? Because these have been squared. So we're going to square them both. That's the exponential property that says when you square a fraction, you can just square the numerator and the denominator. And it's equal to secant squared. But remember that secant squared is the same as 1 over cosine sine squared. No, cosine squared. So that's there. So how do I get rid of this fraction on the left side? I'm going to, on the right side, I'm going to multiply both sides by cos squared. Now remember that this left side is all in a bracket. It's all in a bracket. So I have to multiply the whole bracket by cos squared. But what happens on the right side? Let me just move this over a bit. What happens on this right side when I multiply 1 over cos squared by cos squared? It, of course, cancels out, and I'm left with 1. 1. What happens to this one? Well, it multiplies through to this 1 and becomes cos squared. But it multiplies this fraction over here. Notice the denominator will cancel out with the numerator. So I'm left with, as I've put it through, cos squared plus sine squared. Well, we already proved that in step 1 that this is true. Cos squared plus sine squared is equal to 1. Therefore, this e is true. What about this one? Well, it always helps if you reduce your... We don't have to do much for this one because they pretty much give us right here. All right, let's work on that. Didn't we already prove that tan is equal to sine divided by cos? Now, right away, you could say, well, therefore, cotangent is cos over sine. But if you want to see the proof of it, it's like this. Cotangent is equal to 1 over tan. And we've already proven that tan is sine over cos. So we can replace the word tan down there with this, like that. When you have a fraction, which is essentially 1 divided by 1 up here, that's what this fraction is, 1 over 1, divided by another fraction, you simply take this other fraction and multiply the top fraction by the inverse, like that. Well, 1 over 1 times cos over sine is that, which means I've just proven that cotangent is equal to cos over sine, which is what they're asking here. This is what these identities will all be like, proving this using the logic of things you already know are true. Okay, we're going to skip that. Okay, these are origin circles where the circle is not in the center. There we go. Exploring equivalent trigonomic functions. All right. This has to do with when you're looking at a triangle, there's some commonalities. So let's look at this one here, which is a 60-30 triangle. Right? This is 60 degrees in the top, bottom left, and 30 in the right. But let's focus on the 60 degrees. Let's focus on the 60 degrees. So in the bottom left, and we're going to get rid of this. There we go. Well, what is the sine of pi over 3? It's opposite, which is square root of 3, over the hypotenuse, which is 2. So that's the sine of pi over 3. Great. What's the cosine of pi over 3? Well, it's the adjacent, which is 1, over the hypotenuse, which is 2. Okay, great. That is the cosine. Now we're going to bring back the 30 degrees in the top left, and we're going to ignore the bottom right, and we're going to focus on the top left, and we're going to figure out the sine of pi over 6. Well, it's the opposite, which is 1 over 2. And now the cosine of pi over 6 is the adjacent, square root of 3 over 2. like this. That's the adjacent. And there, now I want you to look at something though. All of a sudden, sine of pi over 6 is equal to cosine of pi over 3. And cosine of pi over 6 is equal to sine of pi over 3. Like that. So that means that cosine of pi over 6, and remember that's the same as 30 degrees, 60 degrees, 30 degrees, sorry, is equal to the sine of pi over 3, which is the same as 60 degrees. Notice they both add up to 90. And that means the sine of pi over 6 is equal to the cosine of pi over 3, which in this case is 30 degrees, 60 degrees, and 30 degrees. And they also add up. You will discover this connection between them all. Sine of 20 degrees is equal to the cos of 70. Sine of 14 degrees is equal to the cos of 90 minus 14, which is 76. So as those two angles, if they add up to 90, they will be equivalent, especially in the acute, particularly or specifically for acute, the first quadrant. When you get into other quadrants, you have to do something odd. For instance, if I'm talking about this angle, which is 166, which is also 14 degrees, but this cos 166 is now in quadrant 2 and will be negative, they are no longer equivalent because sine 14 will come out positive. This is, oh, sorry, it should be, yeah, cos of the reverse of that. So instead of, it'll be 76, 180 minus, it'll be 190 plus 104. But cos 104 is in quadrant 2. It'll come out negative, and sine 14 is in quadrant 1. It'll come out positive. So you'd have to put a little minus here to make those quadrants equivalent. But it is the same thing. And if you're ever in doubt, take the sine of 14. I know I'm in degrees here, but I'm just trying to show examples. 0.2419. And take the cos of 104. 0.2419, but negative, and then you'd have to slap a negative in front of it to make them equivalent. So you're going to learn that this 90-degree connection is very important for equivalent angles. And then that is also because the adjacent of this triangle is of this angle up here is the opposite of this angle over here. So the sines and the cosines share. Right? Similar statements. Then they just go on that any sine curve is simply a cos curve out of phase by 90 degrees. That there are these connections between any angle and 2 pi later. For cos curve, a reflection in the y-axis will result in the same curve. That there's rotational symmetry among axes for some of these. And most importantly, that the cosine and the sine are related by 90 degrees minus the angle. So if you can add up the angles, they will be equivalent. This is true for tangent as well. And then you have to understand that in different quadrants, you have to add a minus in front of it, but it still works. Okay, 3 equivalent expressions for the following graphs. There's no way I'm going to finish this whole chapter in the timeline that you need. There's just no way. So I'm just going to look at, the max, I'm going to do this very quickly. Max to max, there's the max. I can see the period's 2 pi. I can see this is a cos curve that starts at 1 and ends and down here. Use transformation cosine function to write 3 equivalent expressions for the following graph. Right. Okay. So let's look at the sine curve. So they're saying this is y is equal to cos. Here's the sine curve right there. I can see that this sine curve will give me the same thing, but it's to the left by pi over 2. So that means this is equivalent to sine theta. How do I move something left? Pi over 2. I add it. So this will create the same graph as a cos curve. So that's 1. Then if I look quickly right here, I've got a cos curve right there. I'll get rid of that. So that's 1. Just write that down. If I look quickly right here, this is also a cos curve, but it's flipped upside down. And it starts pi over. So if I look at that, I do y is equal to negative, to flip it upside down, cos theta plus pi. So that's going to give me the same graph. I can also look at over here. Here's a cos curve upside down, and that's pi to the right. So instead of pi or theta minus pi, I could do the same flip with the minus here and get theta plus pi. There's 3 equivalent graphs, and you can keep going. There's sine curves, cos curves all throughout this. No. You can do that. You don't really need me to do that. That's not that complicated. Okay, 2, classify the reciprocal trigonomic functions as odd or even. No, you can do that with graphing. You can go back and look what odd and even is. Use the co-function identities to express equivalent to each of the following. Okay, that's fair enough. Okay, here we go. Equivalent to each of the following. Which quadrant is this in? It's in quadrant 1. What's the angle? That's essentially 30 degrees. So what's the equivalent angle? It would be pi over 2, which is 90 degrees, minus pi over 6. Put this over 6 by multiplying top and bottom by 3. What's 3 pi minus pi over 3 pi over 6 minus 1 pi over 6? 2 pi over 6. What is the simplified version of that? Pi over 3. So you can see that this is going to be the equivalent to cos of pi over 3, the 60 degrees. Sine of 30 degrees is equal to cos of 60 degrees. So that's 1. You can also say, okay, well, pi over 3 is in quadrant 2 also, which would be pi minus pi over 3, which is cos 2 pi over 3, but it would be negative there, so we would slap a negative. You can keep going to the next quadrant. That was quadrant 2. You can go to the next quadrant 3, which is cos of pi over 3 plus a pi, which is 4 pi over 3. But it's negative there, so we'd have to slap a negative in it. You can keep going to quadrant 4, which is 2 pi minus pi over 3, which is 6 pi over 3 minus pi over 3, which is cos of 5 pi over 3. And we don't have to slap a negative in it because that's in quadrant 4 where cos is positive. So I came up with 4 different cos values that are equivalent to sine of pi over 6 using the 90 degrees and then using the equivalent in other quadrants. Okay, what about this one? Where is it? It looks like it's just short of 12 because 6 over 12 would be half a pi, wouldn't it? 6 over 12 would be pi over 2. Pi over 2 is 90 degrees, so this is all the way to here, but not quite. That's 5 pi over 12, which means what's the little bit left here before I get to the next one? It's 1 pi over 12. So what is the equivalent of 5 pi over 12? It's 90 degrees minus 5 pi over 12. 90 degrees expressed over 12 is 6 over 12. 6 pi over 12 minus 5 pi over 12 is a pi over 12. Since we were talking originally about cos, it's going to be equal to the sine of that. And again, you can find that over and over again in all the quadrants. You could say, okay, well, that's going to be the equivalent to a sine of 2 pi, or pi, which is going to pi minus that, which is 11 pi over 12. You can just keep going. So negative sine of 13 pi over 12, and negative sine of 11 pi over 12. That last one I didn't quite get right. This one is 13 pi over 12. Yeah, this last one is 23 pi over 12. There we go. What about tan of 3 pi over 8 is going to be equal to the cotan of 90 degrees. 3 pi over 8 is in the first quadrant. So it's going to be 90 degrees minus 3 pi over 8. That's the fastest way to do it. Get this over 8, and we're left with pi over 8. So those will be equivalent. And again, you can just keep going. This one is just short of 90 degrees as well. So it's going to be equal to the sine of 90 degrees minus 5 pi over 16. You've got to get this over 16, so you multiply top and bottom by 8. 8 pi minus 5 pi is 3 pi over 16, and it can't be simplified. So there you go. That's the equivalent. Pi over 8 is definitely less than 90 degrees. And the simple version is it's going to be equal to the cos of 90 degrees minus pi over 8. Multiply top and bottom by 4. 4 pi minus 1 pi, 3 pi over 8. And then the last one, tan pi over 6, is going to be 90 degrees minus pi over 6. And it's going to be the cotan. Make pi over 2 over 6 by multiplying top and bottom by 3. And you get 3 pi over 6. 3 pi minus 1 pi is 2 pi over 6. And that can be simplified as pi over 3. So that means the tan of 30 degrees, 30 degrees is equal to, sorry, not cos, cotan. Tan of pi over 6 is equal to cotan of pi over 3, or tan of 30 degrees is equal to cotan of 60 degrees. It's all about the 90. Those are the simplest ones, but as I pointed out, you can find a million variations. Write the cofunction identity for the reciprocal trigonomic functions. It's just the flip. You just have to flip the fractions. It's the same thing. Secant and cosecant will share 90 degrees. Write an equivalent expression for these. Now, these are all over 90 degrees, so you have to be careful what quadrant they're in. So this quadrant that's just short of 1, so that's going to be in quadrant 3, which means the leftover angle, if I'm looking at here, if I find the acute angle of this, we're talking about pi over 8. So that's the acute angle. And it's also going to be positive because sine is positive here, which means the shared angle is between pi over 2 minus pi over 8. You got to put this over 8, multiply top and bottom by 4. 4 minus 1 pi is 3 pi over 8. Wow, how do we make sure of that? Well, that's what calculators are for. So we're going to keep it in radians. We're going to do 7 times pi divided by 8. We're going to find the sine. And we get 0.382. Remember that, 0.382. Then we're going to take 3 times pi and divide it by 8. And we're going to find the cosine. Oops. I did a little bit wrong there. Let's try that again. Yeah, I think I got this wrong, but we'll try it. Well, 0.382. So let's just put that in memory because I already forget what the other one was. 7 times pi divided by 8. Find the sine. Do they match? 0.382, 0.382. They do match. So they're equivalent. Notice that I had to find a cosine in the quadrant 1 to be positive to this, but I could have found it in second quadrant. Second quadrant means if this is the acute angle we're talking about, that means it goes all the way to 8 pi over 8 minus the 3 pi. So we're talking about cosine of 5 pi over 8. However, that's negative. That'll be a negative value. So this is also equal to the cosine the negative 1 times the cosine of 5 pi over 8. Let's see if that's true. 5 times pi divided by 8, make it negative. Oh, don't make it negative yet. Find the cosine. Nope, I got it wrong. Let's find it again. 5 pi, 5 times pi divided by 8 is equal. Find the cosine. Nope, I got it wrong somehow. So, if this is the acute angle over here, and that's that, and that's 1 pi to get to there, 3 pi over 8 should be 5 pi over 8. 3 pi over 8 should be the same as 5 pi over 8, except negative. What am I doing wrong here? 5 times pi divided by 8 equals cosine. Now I'm getting something weird. I wonder what I'm doing wrong there. Let's go back and do 3 times pi divided by 8. And take the cosine. Oh, I'm getting a whole different thing now. Let's go back to take 7. Oh, jeez, I'm stupid. Look at this. Gotta have it in radians, kids. So now we're going to go 5 times pi divided by 8. Should give me the same value, but then I have to multiply by -1. And it does. There we go. And then I multiply by -1, and I get the same value. So you can see you can make it equivalent to quadrant 1 where it's positive, or the negative of quadrant 2 or 3, where there's many more equivalents, by the way. You can just keep going with equivalents. That's 7, 8. Wow, that was just the first one. So there's just no way I'm going to do all of 7 in a week. So cos, this is clearly just past 1 pi. So if I were to draw this, it's going all the way, and the acute angle here is pi over 12, because 12 pi over 12 is all the way to here, and one more makes 13 pi over 12, and that's the acute angle. But that's a negative value here. So that means over here in quadrant 1, pi over 12, the equivalent sine curve would be 90 minus that, and then we'd have to make it negative. So what is pi over 2 minus pi over 12? Have to multiply by this by 6, and then this becomes 5 pi over 12. It's going to be the equivalent to this, but we'd have to make it negative. And of course, you can punch it in the calculator to make sure that this is true. If you want to bring it over to the same quadrant where they're both negative, you can say, okay, I'm going to add a whole pi to this. I'm going to add a whole pi to this. And that's the same as 12 pi over 12. And I get sine 17 pi over 12. And I don't need it to be negative. Let's see if that's true. Let's see if that's true. Is this the same as that? Well, let's just let the calculator do it. Make sure you're on radians. You got 13 times pi divided by 12, and hit cosine. And you get negative 0.96, which makes sense because we're in quadrant 3. And then I put this one in quadrant 3, so it would also come out as negative 0.96. Let's see if it does. 17 times pi divided by 12 sine. And yes, I get the exact same value. So that's if you want to make them equivalent without putting a negative sign in front of them, by putting them in a quadrant where they both come out as negative, because only tangent is positive in this quadrant. Okay, what about this one? This one's clearly over 1 as well, which means it's going to also fall in quadrant 3 where tan is positive. And if I look at it, this is all the way to 4 pi over 4, and the extra distance we're going is pi over 4, which is 45 degrees. And that's one of the few angles where it's going to be the same angle. It's going to be the same as cotangent, because when you take pi over 2 and subtract pi over 4, you get 2 pi over 4, and it ends up being pi over 4. So 45 degrees is the only one that shares itself with the same angle, because 45 plus 45 is 90. So those will be equivalent because this cotangent is in quadrant 1. This cotangent's quadrant 1, which is positive. And this one's in quadrant 3, which is also positive. So they'll be equivalent. You could also add a full pi to it and get 5 pi over 4. Notice that the angle is the same. So tangent 5 pi over 4 is equivalent to cotangent pi over 4 because we're talking about 45 degrees. What about this one? This one is just short of 2. This one's just short of 2. So if I were to go all the way around, that would be 12 pi over 6. But we only make it to 11 pi over 6, which means the last little left over here is pi over 6. One more pi over 6, we make it to 12. So that's the acute angle. Now in this quadrant, cosine is positive. So if I was going to find the tangent equivalent, or sine equivalent, it would be 2 pi minus pi over 6. Well, pi over 2 minus pi over 6. Pi over 2 minus pi over 6. Multiply top and bottom by 3. You get 2 pi over 6, which is the same as pi over 3. So it's going to be the same as the sine of pi over 3. And if I wanted to make it the same in that quadrant, it would be 2 pi minus pi over 3, which is 6 pi over 3 minus pi over 3, which would be the sine of 5 pi over 6, but you'd have to make it negative. Because in that quadrant, it's not positive. Or you can add a full pi to this and make it sine 4 pi over 3 and keep it positive because in quadrant 2, sine is positive. So there's endless equivalents, endless equivalents. So what about this one? This one goes around fully, and it's just uncertain where it stops. Just uncertain where it stops. If I do 8 over, take 8 out of the top one, I'm left with 5 pi over 8. So that means I've gone one full 90 degrees and another 5 pi over 8. Well, 5 pi over 8 is more than half, which means it goes to here, and ends up in here. And that little left over, we'd have to figure out what 2 pi over 8 is, 2 pi minus 5 pi over 8 to figure out the acute. Well, 2 pi over 8, or 2 pi over 8 is the same as 16 pi over 8. If I subtract the 5 pi over 8, we're talking about 11 pi over 8. That's the acute angle. If I want to find the equivalent cosine, I just take cosine pi over 2 minus my pi over 8, or 11 pi over 8, over 8. Let me make sure I got that right. So that one over there goes past by pi over 8, which means the remaining is 2 pi minus pi over 8. No, 2 pi minus, yeah. Let's do it this way. What is 2 pi minus 5 pi over 8? Multiply this by 8. 16 minus 5. Yeah, I got it. It's 11 pi over 8. So that's the same as sine. It's actually the same as the negative sign because it's negative in that area. But let's find the equivalent. So cosine is going to be pi over 2 minus 11 pi over 8, which is, multiply both by 4, 4 over 8. 4 minus 11, wow, we get minus 7 pi over 8. That's interesting, so we got to go backwards. If I go backwards, negative 7 pi over 8 almost reaches the other side. So it's going to be the same as 1 over 8, 9 pi over 8 in the positive direction. That's a mind screw. Now, notice that both are going to be negatives. Let's just make sure I got it right. What's 13 pi over 8? 13 times pi divided by 8. And we're going to take, oh, we're in degrees, so let's take radians. Maybe it's not too late. And take the sign. And remember, it's this. Remember, it's this, negative 0.92. And now we're going to take 9 pi divided by 8. And we're going to take the cosine. Negative 0.9238. Got it. They're both the same. How did I come up with it? Didn't I say it was a negative? It was negative It's going this way, negative 7 pi over 8. Well, 7 pi over 8 is almost a full way back. The leftover is pi over 8. If I go in the positive direction, we're talking about 1 pi plus pi over 8. 1 pi plus pi over 8 is 9 pi over 8. That's how I got to the positive direction of the negative direction. Now, you could have kept this as negative 7 pi over 8, and you will get the same answer. They'll both come out negative, and this will come out negative. It'll still work. I'm just showing you the positive direction in case your teacher says, find me a positive angle. Okay, so what about this? All right, well, what quadrant is this in? This is almost full. It goes 3 over 3 is 1, and then 2/3 is past this. It's in this quadrant. What's the leftover? Well, it's 2 pi minus that. 2 pi is 6 pi over 3 minus 5 pi over 3, which is pi over 3. So it's a 60 degrees over here. So we're going to have to find the 90 degrees minus that for cotangent. Since tan is negative here, cotangent pi over 2 minus 5 pi over 3, or sorry, minus pi over 3, ends up in quadrant 1. So we have to make a negative in front of it. Pi over 2, multiply both top and bottom. Multiply this by 3. Multiply this by 2. And you get pi over 6, which makes sense. And because that's in quadrant 1, we have to make it negative to match this one, which is in quadrant 4, which is, which is negative. So because this one is in quadrant 4 and comes out negative, this one is in quadrant 1 and would come out positive, so we have to multiply it by -1. Let's keep going. I do not think I'm going to be able to even come close to finishing this chapter. We'll just do 6 and 7. Oof, now I just went crazy. I don't even know where I am now. Yeah, I went way too far back. Okay. Okay, show that this equation is true. Will this minus this equal the sign? Well, we've already proven this is true. And it's especially true only for the acute angles here. And they're using this as a drawing. Oh, which is kind of stupid. Show that each of the equations is true. I mean, do we really have to prove it? We've already proven it. Plus this angle is equal to the negative of the other angle. Really? I mean, it always helps if you use a specific angle. So if you put like 30 degrees in here, it's quite obvious that it's true. For this one, they're saying we're going to now have this weird angle here. We're going to do pi over 2 plus this extra angle. And it's going to be the equivalent of negative sine of the angle. Just plug in a specific angle and you'll realize it's true. I really hate that one, but I mean, if somebody really needs it, I don't know. I just think those things are stupid. Okay, state whether each of the following is true or false. If I go around an extra 2 pi, will I end up in the same spot? Of course I will. If I take 45 and add 2 pi, I'm going to end up back where 45 was. Automatically true. Will the sine of 90 or 180 degrees minus my angle be equal to the negative? Well, that's a good question. Let's see if that's true. I guess we're assuming the angle is always less than 90. So if I go to here and subtract the angle, well, this, so we're saying that this is the angle that we're subtracting. Will this be equivalent to the negative sine of that angle? No, it won't. Because pi over here minus the angle ends up positive. And if I slap a negative of a sign in this area, it comes out negative. So that negative screws it up. If you do this, though, then that is very much true. Will this be equal to this? Well, it shouldn't. because 4 pi is the same as going around once, twice, and you end up at the same angle. If you end up at the same angle in the same quadrant, the positive should or negative should be the same. Since this is negative and this is positive, this can't possibly be true. What about this one? If we go pi, which is all the way to 90 degrees, and subtract the angle, in this quadrant, tan will be negative. Will it be equivalent to the tan of the angle itself? No, it won't, because tan over here is positive, tan over here is negative. What about this one? Will, if I go 90 degrees and add pi over 2, sorry, if I go 90 degrees and add the angle, will it be the same as the tan of that angle? It should actually be equivalent to the cotan of that angle, but let's look at it in terms of a triangle. If I draw a right angle triangle to the x-axis, or to the y-axis like that, and draw the same right angle triangle down here, we discover that this length is the same as this length, and this length is the same as this length. Since we're talking about the cotangent up here is the opposite of the flip of the tangent. So the flip of the tangent, and we're talking about this angle here, normally it's the opposite over the adjacent would be the tangent. So let's call this A. Let's call this A up here. Let's call this B, which makes this side B, and this down here is A. So that means normally the tangent would be B over A, but the cotangent is A over B. A over B in the bottom triangle is the same as A over B in the bottom triangle is the same as cotangent of that specific angle. Same angle is A over B. So that means when I have pi over 2, the cotangent of that angle will be the same. Therefore, it will not be the equivalent to tan of that angle. No, it will be equivalent to cotan of that angle because they share the same sides. And you can always just pick a specific angle. Like if you say, okay, pi over 3, let's prove it. So let's pick a specific angle. What's pi over 2 plus pi over 3? Put them both over 6. It's 5 pi over 6. So the question becomes, is the cotangent of pi over 6 going to be the same as the tangent of 5 pi over 6? It's quite clear that that's ridiculous. Or sorry, since I've used pi over 3, will it be the same as pi over 3? It's quite clear, I believe, that this is not true, but it's a good thing to check it because I'm working on steam here. I could easily be wrong. So, is 5 times pi divided by 6? We're going to clear our thing. And we're going to hit cotangent. So we're going to save that, minus 1.73. Is that the same as the tangent of pi over 3? (1.73), and let's recall the number. Negative 1.73. So they are equivalent numbers, but because they're in 10 and that one is positive, and cotangent, the other one is negative. So I actually got that wrong in terms of the angles. And instead should have focused on that this is going to be positive and this is going to be negative. Okay, what about this one? Is this going to be the same as sine of the negative angle? Well, let's see. If I talk about an angle, I'm up here. If I talk about a negative angle, I'm down here. It's clear that the positive angle is not the same as the negative angle, right? I mean, especially since sine down here will come out negative and sine up here will come out positive. However, if I start at this angle here and go around 2 pi, I end up at the same angle. I end up right up here. So it's clear that it's not the same as the negative sine of that same angle because the negative sine of that angle The negative angle sign would come out negative. The positive of this angle come out positive. They cannot be equivalent. You'd have to slap a negative sign in front of one of them. There you go. Messed up some of it, but that's okay. So that's 7.1. Let's see if I can just get that on the internet. That's 7 and 7.1.